Hi everyone, what's up? We have this Redmi mobile phone that I received from another shop, and the phone is not charging. Actually, the phone is showing charging, that kind of fake charging. So I connected, the phone is already dismantled. I connected this phone on charge more than an hour ago, but if it's still connected, if I press the power key, right, you will see that the phone is charging, stopped at 1%. So that's how it will be even if you leave it on charge for 1 week. If you take a look, and the most interesting thing, if you take a look at the charging ammeter right here, you will see that there is no current consumption. And it's kind of complicated a little bit because when you disconnect the charger, connect it again, you can see the battery is draining instead, because it doesn't even show the 1% that it was showing before. So yeah, without wasting a lot of time, let's go straight and see how we can troubleshoot this fault. I will remove the PCB. Well, if you haven't followed me, subscribe to my channel. I create educational content, mobile repairing educational content, so you will always learn if you follow me. You will always learn one or two things if you follow me. I've solved this particular fault in a lot of phones before, and I've made a lot of videos concerning this fault. Different ways to solve, because yeah, it's electronics. Because you solve it this way doesn't mean that all the time you will solve it that same way when you come across different types of mobile phone, or even the same mobile phone you get. We have the motherboard here. So from how the phone is acting, we cannot suspect the charging card. The charging card should be okay, because first the technician told me that he changed the charging card, and yeah, it was still acting the same. So the charging card from here to the connector should be okay, which means that we have to start from the connector here to the charging circuit. To make things easier for us to know exactly where we should go straight to troubleshoot this fault, we should use our schematic software, which is Orion Schematic. Let's use this to locate the charging IC. Okay, this should be the charging IC. Here we have the VPH power, but this is not the charging circuit, it's not the charging guideline. So if I come to USB, okay, you will see the charging diagram. So let's take a look. You will see that we have the VBus, input, right? So this is the connector. Let's go. We have the VBus input into the OVP IC. So this is our first suspect here. So what we will do right now, we locate this circuit, we test if the VBus input is getting in, and we see if we are getting a stable voltage out of the IC. So that's exactly what we will do first. Always make sure you remove the cameras anytime you want to use your heat gun, because you might think, yeah, I'm not going to work on the section where the cameras are being plugged in, but yeah, at the end you will see that you have damaged your customer's camera. Okay, now that we have the shield off, you can see have our first look at the OVP and the charging IC. Let's set our multimeter to continuity test mode. Perform a cold testing. The red probe to the ground. Use the black probe. This should be the input 5V. The reading that you see on our multimeter is okay. And we have the OVP output, and that reading is okay. So I just wanted to make sure that the OVP is okay when it comes to the diode reading of the IC is okay, right? So yeah, because that's okay doesn't really mean that everything is good. So what we will have to do here, we will have to do something to be able to test the OVP IC if it's okay when it comes to the voltage. I will solder that cable there. Let me take a look at the schematic diagram so that you will see what I'm doing. You will understand what I'm doing. Because if I don't do so, a lot of people won't understand. So you see we have our schematic circuit here, right? You can see that this is the VBus input to the OVP IC. So what I'm simply doing is I solder the cable to this point. So this is the VBus input here. So there is nothing really complicated about that. I solder this cable here because I want to inject voltage. Not because I'm injecting the voltage to find a short. To find a short because the PCB is not shorting. I will show you exactly why I'm injecting the voltage right there. Let's go back to the PCB. Set our DC power supply reading to 5 volt and we set our current 2.5. What we do, we clip the black probe, we clip the red probe to the cable that we soldered, and the black probe to the GND of the mobile phone. You can see we have, and we use our multimeter, set our multimeter to DC range. That reading from our DC power supply, that reading is okay. That's not bad. Like I said, we are not looking for a short, right? So if I test the VBus input, we should get a 5 volt. So that's 5 volt. Let's check the output. And there we have, let's see. I'm taking a good look because I want to see if you are getting a stable 5 volt. So we can test that from this capacitor here. Leave it there for a few seconds to see if you will get any fluctuating voltage. Okay, so that's okay. The reading there is okay. If we go to the schematic diagram again and we take a look at the VPH and the VBAT. So if we come here, we take a look at the VBAT. We have to test the VBAT voltage, which is the output voltage from the charging IC that charges the battery. So if we test, you will see that we are not getting a stable voltage there, and that's possibly the reason why the phone is not able to charge. We are not getting a stable voltage. So apart from not giving a stable voltage, that voltage that the charging IC is giving out is kind of low to charge this battery. So I will we'll do direct testing in a battery connector to see how many volt we are getting from here. You can see, you can see the voltage is not stable, right? The voltage is not stable. So the problem of this mobile phone is the charging IC. So let's take a look at the number of the charging IC, then see if you will be able to get it. Though I doubt if you'll be able to get it. I told the guy who gave me the phone already that this problem can end up being the charging IC, and we will have to replace but the main problem will be to get the IC. So I will just check the number so that I can look at the PCBs that I have. Like, I always do swapping from other PCBs, swap ICs from other PCBs. You can see the number, so I will just take a look and see if I have this IC in one of my scrapboard PCBs. Then we will see what we do. If you don't have the IC, I will still have to check on what we will do. So after checking, the IC is not available, which means that we just have some things to try, even though I don't really like working charging fault this way, but it's okay. The first thing that we will do, we will just heat up the charging IC a little bit. Just heat up to make sure that if it's an open circuit, everything will be connected again. So we just apply a little bit of paste. So if you don't know what you are doing, and if you are not that good in reballing, I will say you should either give back the mobile PCB to the customer, because there are times that you will heat up the IC like this and will have to end up reballing the IC. So if you are not good in reballing, I would prefer you give back the phone to the customer, because after heating, the phone might stop switching on and you will have to reball the IC. But if you are good in reballing, then yeah, that's okay. There is no risk in doing so, because if everything comes, then you will be able to handle. After heating the charging IC, we will inject the voltage into the V-bus again. Let's test the output. That reading, you can see that the reading is going a bit higher right now, but still not stable. So yeah, the only option here is to replace the charging IC, but there is something that I can do right now, and I can do right now, which, like I said before, we might end up doing something that I don't like doing, but that's the only option that we have now. And also, I've talked to the customer about this. I've talked to the guy who gave me the phone, and yeah, explain how we can bypass this fault and see if the phone will charge normally. So what we are going to do, we have to look for a PCB, any type of PCB. Then I will show you the component that we will remove from that PCB. So if you take a look, you will see that we have one scrap PCB here, and what I'm doing, I want to remove this diode. You will see how I'm going to use this diode to solve the fake charging problem in the other phone and make sure that the phone is charging normally, at least, because that's the only option that we have. But if you have the charging IC, if you are able to get, you go ahead and change. You have seen me upload a lot of videos where I go ahead to change the charging IC when I have this type of problem and the IC is available to change. But now that the IC is not available, this is what I have to do. So now that we have our diode out from the scrap PCB, let's go back to the PCB that we are working on. So this is the PCB that we are working on, and let's see. Let's apply some solder here. I'm going to explain what I'm doing, so don't worry. And now I bring up the diode. Then we are not going to put this diode anyhow. I have to look at the mark side of the diode. So what I want to do here, I want to connect this diode from the V bus to the V bar in forward mode. That's why I'm looking at the side of the diode. You will always see that we have one side here, and just for you to be sure where we are connecting this, we will go to the guideline. If I come here, you will see that we have the V bus. This is the spot, that's the other spot which are jumper points, right? So what I'm doing, I'm connecting the V bus to the V bar in forward mode using the diode, and the connection from the V bar to the V bus will be in backward mode. So we are using a diode here so that if in case this works out perfectly, the phone won't charge itself, because without the diode in backward mode from the V bar to the V bus, the phone will send back voltage to the V bus, and the phone will show charging all the time, even when the charging is not connected, even when the charger is not connected. So we are doing this to take in the V bus voltage and stop any voltage from this other side to go back to the V bus and charge the phone. So let's go ahead. Okay, that's all that I wanted to do. Now that we have the diode installed, you can see I've connected the screen connector. So I will go ahead, plug in the charger into this phone, and first I will take a look at the arm charger to see if I will see any abnormal reading, and the reading is okay there. This is not the best thing to do, but like I said, this is the only option that we have. I've done this a lot of times because I'm out of options, out of ICs. I don't have the IC to replace. But this is not something that you should do when you have another option, like to just change the charging IC. If the charging IC is available, go out and change it. But if it's not available, yeah, I do this. It's not a big update. It's not the best option, like I said. You go ahead and connect. So if I click here, you will see that we have 1% here, right? If I click, you'll see we have that's 1%. So we are going to leave it for like 5 minutes, to see if the phone is going to charge. So it's been 4 to 5 minutes. Let's see if the phone is charging. You can see it's charging here. So that's 5%, right? That's 5%. And also another thing is to switch on the phone and see if the phone is charging when it's on. If the phone is charging when it's on, then everything should be okay. The phone is charging, and you can see we have 6% already, so the phone is charging normally. So this is not the best success, but yeah, we succeeded. A lot of people are going to use this method to solve, just like me, when they are out of IC. Yeah, but yeah, it's working, and it will work for long. So yeah, that's it. Well, I'm saying it's my right here. You can follow and also check my other videos where I solve this type of fault differently. If you are not okay with this method, yeah, well, follow, subscribe for more videos, and also get my courses using the number right here.